Hi, my friends. My name is Gabby, and I'm going to present to you a little bit about my ongoing research from my PhD. And this paper is entitled Limb Muscular Anatomy of the Thick-tailed Opossum, Luteolina crassicaudata. Well, as most of you may know, marsupials are split in two major groups. The first one is the neotropical marsupials, divided in three orders: the Delphimorphia with the opossums, Microbiotheria with only one living species, the Monito del Monte, and Paucituberculata with the shrill opossums. And the second and most diverse group is the Australian marsupials, composed by four orders, with Paramelemorphia with bandicoots and bilbies, Dasiromorphia with carnivorous marsupials, Diprotodontia with a lot of different species like koalas and kangaroos, and Ontorictomorphia with the marsupial mole. Well, so marsupials group are split in two cohorts, Ameridelphia and Australiadelphia, and despite their classification appears to be related only to their geographic distribution, the Microbiotheria order here present in South America are actually more closely related with Australiadelphia group, with both morphological and molecular evidence for this phylogenetic relationship. Well, to talk a little bit about the history of myology in marsupials, it all begins with very old studies of gross anatomy, most of them with no or few recent reviews. This one, I believe it is the first paper that I found talking about the myology and describing myology in marsupials is from Tyson from the 17th century, using the Virginia opossum, the Delphis virginiana. Here, after that, we have anatomical and descriptive studies used as models in marsupials, so we can study through them. And it is important to notice that until then, all the studies with American marsupials used always the same species, the Delphis virginiana. So here we have this opossum, and then the first studies with Australian marsupials using the eastern qual, the Dasyurus vivirinus. And we start to have a few studies with ecomorphological and functional morphology analysis from American marsupials. So again, they use the Virginia opossum, but to compare it to the water opossum, the only true semi-aquatic marsupial that we have. So they have very different types of locomotion since the Delphis is more scansorial. And we have a beautiful paper from Christina Go, actually several papers, that she described a lot of species with different types of locomotion, including terrestrial, scansorial, and arboreal American marsupials. But the idea in her work was to infer the locomotion of extinct species. So she did not describe each species. We don't have yet the entire description of these species in a separated paper, for example. And what do you have about Luteolina myology? I could only found this paper is about the description of the masticatory myology of Luteolina, showing very, very strong masticatory muscles that corroborates the idea that she is one of the most carnivorous American marsupial that we have. And beside that, Luteolina is our weasel-like marsupial here in South America with a very elongated body, and the short limb is very, very close to the ground. And it has small ears, which is unusual for Didophytes marsupials. And besides that, this species is restricted to flooded areas. So we know that some papers call this species as terrestrial and others as kind of semi-aquatic because it is an excellent swimmer. For that reason, the aim of this work is to describe the limb myology of Luteolina crassicaudata with morphological comparisons to other American and Australian marsupial data available in the literature, and to make inferences about its functionality. The myological traits here observed are hypothesized to reflect the level of terrestriality and or semi-aquatic habits of Luteolina. So the material and methods, we dissect 4 specimens of Luteolina here in the mammal collection of my university, UFMG. The specimens were tanned, skinned, eviscerated, and preserved in 17% ethanol. And muscles were dissected, identified, and their attachments were listed and described. After muscle identification, we weight each muscle and the entire limb to access quantitative information and to compare with both neotropical and Australian marsupials with different types of locomotion with muscle weight available in literature. So we use Argo for weight data of neotropical marsupials and Warburton and colleagues for Australian marsupials. This comparative anatomy analysis, was only possible for hind limbs since we did not find papers of forelimb myology with raw data of weight available. So, as this is my ongoing research, we are still working with dissection photos. So, in this case, we have 2 different atlanto muscles, Scapularis muscle. So, this muscle connects the scapula to the axial skeleton and also to the occipital bone, together with the rhomboid muscle. So, in this case, here in marsupials, we have 2 different muscles, and in placentals, we have only 1. And this condition of 2 different muscles is considered plesiomorphic condition for both marsupials and eutherian mammals. So here we see that this feature is shared between Luteolina and Asiurus, the carnivore Australian marsupial. And the same feature is shared also with Mephitidae and Mustelidae eutherian mammals, in this case with the weasel-like Mustelidae gallictis, in which these muscles are also named Homo transversarius. Together, these muscles are very efficient to advance and rotate the scapula in the parasagittal plane and laterally flex the neck. This also shows how nice convergent evolution works because they are 2 similar species with a very far away phylogenetic relation. And another interesting feature found was the accessory head in the triceps muscle that helps in the limb stabilization during the cursorial locomotion. So this morphology is most commonly found in placental carnivores, as the ocelot, for example, in the second picture. And actually it's more commonly found in cats in a general way. So this was not found in other papers about marsupial myology, including dissections of carnivorous marsupials as Tasmanian devil and the quail. And another interesting feature in the forelimb is the morphology and the size and the attachments of the Homo hyoid muscle. So this is the attachments of the Homo hyoid muscle in Luteolina. Here we have a human scapula, so we can see where is the attachment of the Homo hyoid muscle in humans. And here in the arrow is where is this attachment in Luteolina. So it's a very, very far attachment. Is a larger muscle in the marsupials. And here we need to compare because we did not have a lot of works with our specific animal of study. So we need to compare constantly with the human anatomy. And here we see in humans how our muscle is very short and the connection in the scapular is very near to with the clavicle, And in Luteolina, we can see that this attachment is very, very far away since the arm is already disconnected from the actual skeleton. And about possible functions of this different morphology in the Homo hyoid muscle, maybe could help in the mastication or swallow activities. Could be at least a type of predation habits with the neck because opossums are commonly to handling their food constantly. And we can see that even doing this, the first attempt in the prey is most of the times with the head. So they need a very strong neck to do this approach. But this is a difficult information to suggest because we have a very gap in behavior studies in marsupials. And here we have the analysis of muscle wet weight proportion. So it shows us that the heavier muscle was the triceps, as expected, represented by the extensors of the forearm in the first charts, and its high influence in terrestrial locomotion. For that reason, we made a second chart without the triceps muscle, as it could be hampering the weight distribution of the other muscles. So this showed the difference in the other muscle groups, showing flexors and extensors muscle groups biggest than the others. So this could be related also to handling food action. Well, the paper will provide both extended and summarized muscle descriptions in table form and also the extended text, because I realized that during these sections it's very useful to have both brief and detailed descriptions. So keep it in the paper will help future researchers during data collection. And here we have the results of the hind limb, and we did the muscle weight proportions of neotropical species with different locomotion habits. So the chart here shows the hind limb muscle weight proportion. In purple is always Luteolina, and overlapped in gray and other colors is other species. And here in gray is Didelphis muscle weight proportion. So we can see that Luteolina has much more gluteal and hamstring muscles than Didelphis. And these groups of muscles are very useful to run. And since Didelphis is a more scansorial species, they perhaps need less mass of this muscle than Luteolina. Here we compare with the most specialized arboreal marsupial here in South America, is Scapularis, and we can see that the mass distribution is very, very different, because Scapularis has a more concise distribution of muscle mass than Luteolina, probably related to the need to stay well stabilized in branches. And here we compared Metachirus, that is a very cursorial and terrestrial species of American marsupials, and we can see that Luteolina and Metachirus almost completely overlaps one and another. So it's very interesting to realize how their muscle mass distribution is very, very similar. So apparently here, the myology reflects much more the locomotion habits than a phylogenetic signal, since all these species are from the same family. And here we did the same analysis to compare with some Australian marsupials with different locomotion habits as well. So here we have Cetonix, the quokka, is a hopping marsupial, macropodid. And we can see, as expected, that Cetonix has a much more gluteal muscles than Luteolina for this action of hop. Here we have compared with Trichosaurus, the common opossum, and we see that actually their distribution is very similar. It's not that different from, for example, Scapularis and Luteolina. And here we compared with the Zudum, the other cursorial and terrestrial Australian marsupial, and they kind of overlap a little bit, but Izudum has much more hamstring muscles than Luteolina, so it probably runs more than Luteolina. So take-home messages. The main observations in lean myology in Luteolina show its correspondence with both Virginia opossum and the quoll morphology analyzed through literature comparisons. Luteolina also showed a weight proportion distribution in the hind limbs very, very similar with the brown four-eyed opossum, the Metachirus, the most terrestrial species in the Didelphimorphia, showing us that Luteolina is much more terrestrial than a semi-aquatic marsupial. And also we observed a few convergent features with placental carnivores as the ocelots and the grison. And besides, Didelphis is frequently considered as the most generalist and primitive species in the Didelphimorphia order. However, this could be due to the major focus of studies in this genus, or actually, as we saw, the same species as the Virginia opossum, and the lack of information of the genera that might be hampering interesting information of muscle evolution in neotropical marsupials. So I would like to thank the ASM to do this amazing meeting in a virtual way, so all over the world we can participate. And a special thanks to my supervisor, Fernando Perini, and all my friends that helps me with this work. And any thoughts and ideas, please just contact me here in our social and email. Thank you very much.